My name is Lou Schmidt. I'm a director, SE, at Extreme Networks, and I'm coming to you from my home office in San Jose, California, where things are marginally less smoky today. We like that a lot. So today I'd like to talk to you about our edge computing and give you a demonstration of how this could work for you. So we call it integrated application hosting. And what it is we have put a KVM compute complex within certain of our switches. This is not unique to any one switch line. This is available on our VSP series, our SLX series, and our XOS series. And the way it works is we have the virtualization infrastructure running within the network operating system, but it is completely firewalled from that network operating system, yet it has a dedicated data path, at least one dedicated data path, a flexible in-band and out-of-band options, and it's got dedicated storage. So what are the advantages of doing it this way? Well, the first thing is we have pretty much the fastest connections in the business. The minimum connection speed you're going to get into the forwarding plane, and this will show up just like it is an Ethernet port within the system, will be 10 gigabits per second. Some switch models offer dual 10 gigabit ports, so you have the ability to run some very, very serious bandwidth. And you also have dedicated CPU, dedicated memory, dedicated storage. So what would you do with this? You could dynamically deploy a compute resource to troubleshoot a problem. Pull packet captures, do your pre-analysis right there to speed up your troubleshooting and get faster mean time to innocence, right? Everybody wants to blame IT when some application stutters. You can push all the way down to the edge in your troubleshooting. You can also use this to secure select traffic if you're running particular applications that require very high levels of security. You can also do path monitoring. Another example that I'm going to show you here is securing select traffic. You could run a firewall inside the switch. So if you had a remote site that required firewall and switch capability, you could put the whole thing into one unit. And you get cost savings due to decreased complexity. You don't have extra cables to fail. You don't have to eat another rack unit of space. It's very, very convenient, and you can dynamically control it. So what I'm going to show you now is the installation of a firewall into an XOS-based switch. In this case, it's an X465. And I chose the firewall pfSense simply because it's free, it's widely available. I've tested a number of commercial distributions. So far, I've only found one firewall that doesn't work, and that is a firewall from a competitor. So that one does not work, but a great number of them actually do. So let's go ahead and have a look. We've moved the file to create the virtual machine into this switch, and in this case, we're going to create a virtual machine based off the freely available firewall pfSense. We've tested with a number of other software. I chose this because it's a common use case and it's common software to deploy. You can choose to buy services to support it if you like, and it runs pretty well on most platforms. So first of all, let me show you where you are and a little tip and trick here. So if I come up to here, you'll notice that I see the file. It's a QCOW2, which is a QEMU copy on write file. And if I show my path, you'll notice I'm in user local VM packages. So when you log into the switch, change directory into user local VM packages, and then use the procedure outlined in the XOS user guide to actually transfer the file into your system. So it's very well detailed and has all sorts of great tips in it. Highly advise you use that. So in this case, I'm in user local VM packages. Now understand, it could be on your switch that you go into this and you can't get in and you say, my gosh, what's wrong with my switch? Well, there's nothing wrong with your switch probably. The problem is you might not have the appropriate license, which is a core license, and it requires that to even go into this directory. But if you want to see if the module is present, and you'll notice here that I see a switch and a serial number for the switch, and I also see an XN SSD 001 120-1, and it's a tenant serial number. This is only the case for the Exos X465 switch. So I'm going to create this virtual machine. I'm going to name it pfSense. And now you'll notice I have two options. I can create it using an image, which was the aforementioned QCOW2 image, or I can use an OVA. You folks are probably really familiar with OVAs. The challenge that I've noticed is OVAs sometimes don't translate over cleanly. So it's always good to try it first, but if it doesn't work, don't assume that the virtual machine won't work at all. Step back, create your own QCOW2 image, and then transfer that in, and it may work. So in this case, we're going to use an image. We're going to use pfSense QCOW2, and now we have a few options. If I hit the question mark here, I can say CPUs, memory, and VNC. Let's go ahead and use all those options. I'm going to give it 2 CPUs. I'm going to give it 2048 meg of RAM, 2 gig, and I'm going to assign a VNC port to this thing, VNC port 0. Now the VNC server is actually internal to the system and tags to 127.0.0.1, and you need to create a tunnel to get into that. I'm going to show you how to do that in a minute. Right now, it's building the virtual machine, so the virtual machine is now successfully created.
Time was compressed a little there.
VM, you'll see that we now have a virtual machine PFS, but one thing, if we take a look at the virtual machine itself, you'll notice we have no attached switchboard. So now we need to configure this virtual machine. We will configure it. So configure VM PFS add question mark. Now I have a choice of 2 different things. The ports mode allows me to map the entire port to the virtual machine. And then there's the virtual interface, which allows me to do the server IO based virtual function. In this case, I'm going to choose the virtual interface. I've configured port 57 on the switch to give us this. And I have the inside interface sitting at inside VLAN, which is the inside of the firewall subsystem, VLAN 10, and I have the outside, which is VLAN 100. So if I add a virtual interface, I'm going to add it from port 57, and then I'm going to use VLAN 10, and I'm going to give it a name of inside. If you don't give it a name, it will automatically create one. You'll notice it creates that virtual interface and it gives it a MAC address. Now let's go ahead and do this the easy way. I'm also on port 57. I'm going to give this one the name of outside. You'll notice I changed my VLAN to 100. Now we have mapped 2 ports. There is one other port you can map with this that doesn't show up when you question mark, and that is a management port. And when you add the management port, it will not connect to the forwarding plane. It will actually connect directly to the management port, either on the front or the rear of the switch that you've chosen. Caution, this could put production traffic into your management network. So please be careful about this. It's a 1 gig port. You have a 10 gig port with these directly connected inside ports. And in this case, we're sharing that bandwidth, but in management, it's possible to overwhelm that port with too much data or your management network. Most management networks are not designed for production type traffic, so please be careful. So in this case, we've now mapped it. If I do a show VLAN or show VM pfSense now, you'll notice that I now have 2 virtual interfaces and they're inside and outside. So let's start this VM. So it's going to go ahead and start up. Now there are 2 ways to access this VM once you've started it up. One is you can open a console. So you'll notice I'm here, but I'm not getting anything. One of the challenges that we ran into with pfSense is that by default, it does not detect this port for some reason. It does not start up its Getty process. Now, it is possible to go in when you create the virtual machine and enable this, but remember how I set up the VNC port before? Now we have the ability to go in and do this via VNC. So first of all, I'm going to go ahead and Control Y out of this. That's a very good key combination to remember.
because it will drive you crazy if you're trying to get out of a serial console inside the switch.
Never forget Control
Please
Y.
remember that. Okay, so we have a port up and running at port 59. So what we're going to do is we're going to create a secure shell tunnel on the admin account to the address of the switch, tunnel it, and we're going to map port 5900 of 27.0.0.1 into this so that I can get to it. It's going to give me the, ask for my password. Boom, tunnel's up and running. So if I go to my remote access here, you'll see I've pre-configured this. And I want to open this, bang. There is the console for my system. So now I got to go through the configuration. I want to do the WAN. So I'm going to use, because it will configure in the order that it was given. So I gave it VLAN 10 inside first, VLAN 100 outside second. The port IXV1 is going to be our outside port. And I wanted to use IXV0 is my inside port. And these are my mappings. It brought up the web interface and bam, you're up and running. So you'll notice that we show a WAN interface and a LAN interface. These were both pulled from, one was pulled from DHCP, 192.168.1.1 is the default network that pfSense wants to use. Fortunately, I have created that subnet inside of my inside interface. So let's take a look and see if we can get into that particular management interface. And now I'm going to go into this. I'm going to get the security warning on Firefox. I'm going to accept the risk and continue. And now you'll notice that I'm at the configuration screen. The default password is pfSense. So I'll go back to this and type pfSense. And now you're in actually starting to, and now you could configure this firewall just as you normally do. So thank you very much. And you get a lot more information on that from the pfSense website. Thanks for checking out this demo.
So let me go ahead and ask at this point, are there any questions?
Sure, we've had a few questions come in, Lou. First one that came up was, we know that it's not only available in XOS, but it's in VSP and SLX as well. What are the main differences in this technology as far as the support goes between VOS and XOS and SLX?
Thank you. So VOS and XOS are pretty much very similar. The command structure to enable the systems are different, slightly different, based on the composition of the network operating system, but the file formats they support are the same. There's a few extra commands in VOS. There's one extra mode for what you can do with the ports. Now, the SLX is where it gets very different. So one key thing, we do not prevent you from putting an arbitrary virtual machine onto VOS or XOS. So you can try to put any virtual machine on there you want. I've put on Ubuntu VMs just to check something out, the desktop version, because I can VNC into it. So there's all sorts of possibilities there. The SLX is different. The SLX was the original deployment of this system, and it was designed to work with what we call the TPVM, or the third-party virtual machine. You'll see this is preloaded on all the platforms, and it's basically an Ubuntu server instance that has been tested with the virtual machine complex to make sure that everything is working. And we actually support the official version of that. If you use that, it will work. So that is the big difference right there. So you should look on the XOS and the VSP portions as being miniature servers where you can load your own virtual machine. You should look at the SLX as being an application server, because the third-party virtual machine can run Docker, it can run Kubernetes. It's completely unlocked, and we give you root access. Anything you could do on Ubuntu server, you can do on the SLX TPVM or the TPVM on VOS or the SLX, or I'm sorry, on VOS or XOS. I'm gonna take another question in just a second. I just wanted to point out this eye chart. This sort of calls out here. We have Various capabilities on these. Our sideband data, what we call our insight ports, will always be 10 gig ports. You'll notice that some of these have 2, some of them have 1. For example, but we have some devices that have a higher amount. For example, the X695 has 6 processor cores available, 14 gig of RAM, 128 gig of storage, but only 1 insight port, which is why I would recommend you use virtual interfaces in that instance. It's 10 gig, you can share it, but it is, it's got a lot more CPU. The VSP 7400-32C, which is a 100 gig switch, has the same complex, 6 cores, a little less memory because the NOS needs just a bit more at 12 gig, but it's got 2 of those ports, right? The only switch that does not present to sideband port 2 is the SLX 9240, but you could run a virtual machine, say a DHCP server or something, coming out of the management port. Do we have another question?
Yes, I mean, you've alluded to this before earlier in the presentation, but we should probably emphasize it anyway. Is integrated application hosting supported out of the box?
It is, if you have the proper license, yes. So integrated application hosting is a licensed feature and requires an advanced license, for example, a core license on an Exos device. So, but if you have a device that's capable of it and has the memory module, the only thing you need to do is flip the bit on the license. And I'm just going to take a second. I'm going to go a little bit into the TPVM here. The third-party virtual machine, which will eventually be renamed, probably to Open Application Engine, is that prepackaged system I was telling you. Now, it's more than one thing I'd like to call out. Not only do we have a sort of a tested version of Ubuntu here, but we also preload it with Docker, iPerf, TCP dump, T-Shark, Wireshark, a few other tools. The next version of this, I can tell you this because I've seen it, will include a GUI based on Webmin, so that if you don't want to, if you're not completely comfortable digging around in a Linux box to get to logs and such, we're going to simplify that for you. But the Open Application Engine is just like any other Ubuntu server, right? If you're going to migrate between versions, you can do a do distribution upgrade. You can back this thing up. You can run high availability if you happen to have 2 switches and you have the network together, and it will run this way. So do we have another question?
Absolutely. Hold on a second. Let me see what we got going on over here. So somebody asked, how are the sideband ports connected to the VMs?
Okay. So the sideband ports are connected. First of all, let's talk about, let me go back and emphasize this. One end of the sideband port is directly on the forwarding plane, right? It is a hardware port on the forwarding plane switch chip. The other end of it can connect in a different mode. So you can either take the entire port. So in the case of the X465, I have one sitting here keeping the room nice and warm. Ports, it's port 57 and port 58. I can either grab the entire port, and if I do that, then if I'm sending 802.1q tag traffic up that port, just like any other switch port, I can have my virtual machine, if it understands tagging, grab that traffic and do things with it. So there's times when you really want that, especially if you're running a virtual machine that does not understand the IBGXE driver, which is the 10 gig driver, I believe, that we use for the virtual interfaces. So if you can't get it to work with virtual interface, try to get it to work in port mode because it uses different drivers and it does depend on your host OS. I have run into 1 or 2 instances where this was a challenge. And then there's the virtual interface mode, which you will take a specific tagged VLAN and create a virtual interface that you present to that virtual machine. Now that has some interesting connotations. For example, if you have a single 10 gig pipe coming up, which, oh, it's only 10 gig. Well, that's actually quite a lot of bandwidth, right? I can take, say, port 57 or port 63 on an X695, and I could slice that thing up with tagged VLANs. Not only that, I can also share VLANs. So in the case of connecting through the port comes up, I grab the whole port, that's it. No other virtual machine can get it. So if you're on a device that has a single port available, like the 695 or one version of the VSP 400, and you map that entire port to the virtual machine, you're done. You can put another virtual machine on there, but it can't talk to the forwarding point. But if you use virtual interfaces, not only can you map more than one virtual machine to it, and yes, we can run more than one virtual machine at once. That's a point I hadn't even mentioned. But you can also create a shared VLAN between those two virtual machines. So I could take port 57 VLAN 10, which was my inside on this demo, share it to do two virtual machines that are both on the inside interface, and they can talk to each other that way. Otherwise, they can't talk to each other. All right, let's see. I think we talked about the SLX caveats, being that it requires that you run the application. And the insight ports, one other key point about the insight ports is that you can apply filters to those ports inside the switch. So you could say, I'm going to map VLAN 10, and then I'm going to take VLAN 10 as its entity, and I'm going to mirror the traffic from VLAN 12. And I only want to see traffic that looks like this, mirrored to that, and then that'll get sent up. So as an analytic tool, you can actually do your pre-parsing of data on the forwarding plane itself, which is line rate, right? And then filter everything coming in, and off you go. And so on the VSP-based systems, there's Open vSwitch, SR IOV, and VTD. So single root IO virtualization is basically the tag mode where we do the virtual interfaces. Virtualization technology for directed IO is taking the entire port. Open vSwitch is not supported on XOS, so you won't see that option there, but you do have that option on the VSP. Do we have another question? Because I see we still have some time.
We still have a little bit of time left. Just to let you know, you have probably a tad less than 7 minutes left, but in that time, could you talk about what extreme support model is for these applications?
Actually, I think I actually have a slide for that. Yes, let us discuss that. So at Extreme, we believe in giving you the tools you need to shoot for the stars. Unfortunately, that means we also have to give you the tools to shoot your foot off. It's a classic Linux saying, but it is absolutely the truth. So you can put on XOS and VOS a self-built QCOW2 or OVA VMware image. I found, as I said in the demo, OVA files can be a bit of a hit or a miss depending on how they map the hard drive. Otherwise, because you want it to be a VirtIO mapped hard drive if you build this from scratch on QEMU. I must highly suggest that if you want to build QCOW2s, get a Linux virtual machine or a Linux box and use Virtual Machine Manager package with KVM and QEMU on Linux. It's fantastic for doing this. Really, really easy. But as we say up there, we require VirtIO. You can put anything you want on there. We're not going to stop you. However, we have tested some applications. Like I've tested Checkpoint, pfSense, IPFire, Palo Alto, Fortinet. They all work. We've gotten those to work. I put that on, it works. However, if you have a problem with it, it's like running a third-party application on somebody else's server, right? If you go and you buy a server from a server vendor, say Supermicro, and suddenly your Fortinet firewall isn't running properly, you need to call Fortinet, not Supermicro. So we support the box you're in, that memory, the CPU, the storage, right? The ability of the system to present you those resources, we support that. But if your application is acting up, we don't support that. We do support the applications that we ship, like the third-party virtual machine or Extreme Fabric Assistant, stuff like that. We will support that. But the thing that we're going to ask you to do if you're having a problem is to spool up the TPVM and see if that works, right? And if the TPVM is working, then the virtual environment is fine. The problem is with the application, and then you'll need to contact the application vendor. So our legal guideline is you can use at your own risk, buy support from the application vendor, but we're not going to block you from using the thing that you bought. And I think we have time for one more question.
Okay, and this is kind of related, but do you have examples of tested and integrated VMs? Do you have any of those available?
Yeah, so,
like what is you have tested and what you've gone with?
Yeah, for example, I've been doing a lot of the testing on the XOS side. I work with a small team, and we look at this stuff. So I've tested pfSense, for example. I've tested IPFire. If you want a really small firewall, open source firewall that's fast as all get out, I suggest you take a look at IPFire. That was really impressive.
Hey, Lou, I just got warned that you are now like under 1 minute. So,
so all right,
I'm
guys.
sorry,
so
but
I just want to let you know we did work with NetBees. We have worked with NetBees. We're sort of monkeying around with it. We also worked with a company called Senitas to do end-to-end encryption. So we have a working relationship with those folks. And I would like to thank you guys so much for coming to check this thing out. Remember, hit up the hub if you have any questions. I'll be around. Other people will be around. We'll answer your questions. We'll get back to you. And I hope you're really enjoying this event and having a fantastic time. You're going to go ahead and drop the axe on me now, aren't you?
Ladies and gentlemen, thank you for joining the Edge Computing with Integrated Applications hosting session.